Problem 1, which is about 3 into x plus y minus 6 whole squared plus 2 into x minus y plus 7 whole squared equal to 12. You might want to write this as x plus y minus 6 whole minus 5, this, right? So minus 5 whole squared divided by 4 plus x minus y plus 7 whole squared divided by 6 equal to 1. Now one thing for sure, this equal to 0 is a straight line, this equal to 0 is a straight line, and you realize that they are perpendicular to each other. So between the two, they would share the major and the minor axis. One of the two would be the major axis, the other one would be the minor axis. This is a number smaller, this is a larger number, right? Above this would be the minor axis, major axis. Above the smaller number would be the major axis. This would be the major axis, right? This would be the major axis. Yes or no? Right? So the major axis would be x plus y minus 5 equal to 0. Yes or no? Right? The minor axis would be x minus y plus 7 equal to 0 would be the minor axis, right? Now, we need to compute the eccentricity of the ellipse, and the directrix would be a line parallel to the minor axis, right? So the directrix must be always of the form, any of the two directrices must be of the form x minus y plus c equal to 0, because the directrix is always parallel to the minor axis, right? Now for any point xy on the ellipse, this condition is satisfied. Now this is x plus y minus 5 by root 2 whole squared. This is distance of xy from the major axis. This is distance of xy, any point on the ellipse from the major axis, yes or no? This is 2, so this would be 1. What happened? What? No, because I had to write it as distance of xy from this line. That's why I wrote this root 2. Distance of any xy from the major axis squared. That is, right? And then this obviously was balancing, plus x minus y plus 7 by root 2 whole squared is distance of xy from the minor axis whole squared. So we have like a pm squared and a pn squared, and this is 2, and this is like 1 by 3, right? That must be equal to 1. So we have like a pm squared by a squared plus pn squared by b squared equal to 1. So a squared is 3 and b squared is 2. Yes or no? A squared is 3 and b squared is 2. Yes or no? So a squared is 3, b squared is 2. I can compute the eccentricity of the ellipse from this. So then we have 2 equal to 3 into 1 minus e squared, right? So 1 minus e squared is 2/3 e squared. E is 1 by root 3. E is 1 by root 3. The eccentricity of the ellipse is 1 by root 3. Yes or no? Are you all there with me? Right? Now, the distance between the minor axis and the directrix is a by e. Yes or no? Distance between the minor axis and the directrix is a by e, right? So distance between these two lines, these two parallel lines is a by e, where a is root 3 and e is 1 by root 3. Clear? Is it all right? So then, now what's the distance between two parallel lines? Magnitude of 7 minus c divided by root 2. That's the distance between the two parallel lines. Difference between the two constants divided by root 1 squared plus 1 squared, right? and that must be equal to a by a. A by e means root 3 divided by 1 by root 3. A by e. Clear? So then I get like a mod 7 minus c is 3 root 2. Mod 7 minus c is 3 root 2. 7 minus c then is plus minus 3 root 2. 7 minus c is plus minus 3 root 2. So you get two values of c, 7 plus 3 root 2 and 7 minus 3 root 2. So if you put c equal to 7 plus 3 root 2, you get one directrix. If you put c equal to 7 minus 3 root 2, you get the other directrix. Yes or no? I have a feeling the mistake that you would have made is, you would have said a squared is 6 and b squared is 4. Some of you may have done this, right? And you realize why that's not the case? Pm squared is the distance of p from major axis, Pn squared distance of p from the minor axis. So if this is the minor axis, this is the major axis, this is the minor axis, then distance of xy from the major axis and the minor axis would be these, and that divided by a squared and b squared. So then a squared and b squared would be 3 and 2 respectively. How many of you made this mistake? Okay, how many of you got it right? You did what I did?
That a square has 6 only, a square has 6 only, and then directrix is x equal to a by e. And
but a squared is not 6.
But instead of that x, we put x minus y plus 7. And you got the same answer.
Sorry, instead of?
Directrix is x equal to a by e.
But a is not 6. A squared is not 6.
But taking a square as 6 and b square as 4, we got the eccentricity as 1 by root 3 only.
You got eccentricity as? Yeah, so eccentricity you will get right. Agreed. Because, hey, realize b squared is a squared into 1 minus e squared. Okay, instead of b, I take k times b whole squared. Instead of a, I take k times a whole squared. Then this k and k will get cancelled, and you will still get the same value of eccentricity. You realize what you have done? I mean, you've taken kb and ka. You will still get the same value of eccentricity that you get from this. Eccentricity is fine, but how about this? You're not going to get the right answer. Eccentricity, I mean, many sets of b's and a's will give you the same eccentricity. So what? Eccentricity could be right. Even if you take by mistake b as 3 times b and a as 3 times a, you'll get the same value of e, because 3 square would get cancelled. That's why you made a mistake an odd number of times, and fortunately you've still got the right answer as far as the eccentricity is concerned, but not this, because now the distance between these two will not be your a by re, it will be my a by re, right? So you would not have got the same value of c for sure, right?
So we replace x minus y plus z by capital X and then x plus y minus y by capital Y, and then we solve with the standard form e by e. And then
No, but that's not the form. That's not Pn squared and Pn squared distance between. So physical form में तो वो नहीं है ना. It's distance of xy from one line, distance of xy from the other line. That's the form that you have to remember. And in fact, let me also tell you, the mistake that you are making is the mistake that terribly qualified people from Fiji made. The professors who set up a question of this kind in a Fiji paper and solved it in a manner that you solved. So even those people made the same mistake that you are making, and they never came to know that they've made this mistake, because who would go and tell them? Alright, so it's a common mistake, and I knew that you would also fall into the trap. And you know, that's the reason, while I was teaching you ellipse, I had that in mind, and that's the reason I said Pm squared, distance of xy on the ellipse from one of the axes, Pn squared, distance of xy from the other axis divided by square of the major and square of the minor axis respectively, that would be equal to 1. That's the physical form of the equation of the ellipse, and that is what you must remember, right? If you remember that, then it does not matter what the equation of the minor and the major axis is, you'll be at home with things. Got me? An ellipse is inscribed in a rectangle whose length to breadth is 2:1. Deliberately I am doing this so that you don't assume that the sides of the rectangle are parallel to the major and the minor axis, which would be your first temptation. You would be tempted to believe that, well, this is the ellipse x square by a square plus y square by b square equal to 1, and there can be a rectangle circumscribing the ellipse whose sides are not parallel to the major and the minor axis of the ellipse, right? Right? So now in any case, this is the ellipse and this is the rectangle. This ellipse is x square by a square plus y square by b square equal to 1. These are the vertices of the rectangle ABCD. Notice that each of these vertices are such that the two tangents drawn to the ellipse are perpendicular to each other, right? And therefore, each of these vertices will lie on the director circle. So if A is some h comma k, then h square plus k square must be a square plus b square. Hk must lie on the director circle, right? Now, this is the director circle. It shares a common center with the ellipse, right? The center of the ellipse is 0, 0. The center of the director circle is 0, 0 and has radius root a square plus b square. This is a h comma k, and this rectangle is such that if this is t, this is 2t. This is half the width, this is half the length, t and 2t. And this is the radius of the director circle, root a square plus b square. This is root a square plus b square. Then we have 4t squared plus t squared, that is 5t squared equal to a square plus b squared. This is root a square plus b squared, right? So t squared then turns out to be a squared plus b squared by 5. So the area of the rectangle is going to be 2t into 4t. The width will be 2t, the length would be 4t. So 8t squared. 8 by 5, a squared plus b squared. That's the area of the rectangle. Sorry? From here. The tangents from A to the ellipse are perpendicular to each other. So A lies in the director circle. That's the definition of a director. That's how a director circle, all points on the director circle are such that the two tangents are mutually perpendicular. So A lies on the director circle. So distance of hk from the center of the ellipse must be equal to the radius of the director circle. So h square plus k squared is a square plus b square. Clear? Normals at A and B to the ellipse intersect orthogonally at O. This is the ellipse. Normals at A and B. This is A. This is B. And the normals at A and B intersect orthogonally at Q. Orthogonally at Q. Obviously, they would be orthogonally means perpendicularly. Obviously, there would be several pairs AB. There would be several pairs AB on the ellipse such that the normals are perpendicular to each other. Normals at these points are perpendicular to each other. So then there would be very many triangles AQB. There would be very many triangles AQB such that angle AQB is 90 degrees, right? Now, we need to find the locus of the circumcenter of triangle AQB. Obviously, for different ABs, you will have a different circumcenter, right? We need to find the locus of the circumcenter. Now, each of these AQBs would be a right angle triangle. And what's the circumcenter of a right angle triangle? Where is the circumcenter of a right angle triangle? Huh? Circumcenter of a right angle triangle? Huh? Midpoint of AB. If there is a right angle triangle, say AB, then obviously if this is the midpoint, then midpoint of AB would be the center of the circle. This will become angle in a semicircle. This will be the diameter of that circle. Yes or no? The midpoint of AB would be the circumcenter. For a right angle triangle AQB, the midpoint of the hypotenuse is the circumcenter. The midpoint of the hypotenuse is the circumcenter. Yes or no? Right. So we need to find the locus of M. We need to find the locus of M. Let's call M H comma K. Let's call M H comma K. We need to connect H and K and then generalize. Replace H by X and K by Y. Now, at A, I can draw a tangent. At B, I can draw a tangent. Right? Let's say these tangents intersect at P. Let's say these tangents intersect at P. Obviously, the normals are perpendicular to each other. The normals are perpendicular to each other. The tangents will also be perpendicular to each other. The normals are perpendicular to each other, then lines perpendicular to each of them will be perpendicular to each other. Yes or no? So the tangents at A and the tangents at A and B intersect at P such that angle APB is 90 degrees. Therefore, P must lie on the director circle. P must therefore lie on the director circle. Suppose P is x1 comma y1. P is x1 comma y1. Now, equation of AB can be written in two ways. One, equation of a chord in terms of its midpoint is t equal to s1. Equation of a chord in terms of its midpoint is t equal to s1. So, equation of AB in terms of its midpoint m is hx by a squared plus ky by b squared is h squared by a squared plus k squared by b squared. Equation of AB in terms of its midpoint h comma k, t equal to s1, right? And equation of AB in terms of P. AB, as far as P is concerned, is the chord of contact, and the equation of the chord of contact is t equal to 0. So AB could also be looked upon as t equal to 0, equation of the chord of contact with respect to P, which is xx1 by a squared plus yy1 by b squared equal to 1. Both these equations represent the same line AB. Both these equations represent the same line AB. So if two equations represent the same line AB, their coefficients must be proportional. Their coefficients must be proportional. That means h by a squared divided by x1 by a squared must be k by b squared by y1 by b squared must be equal to this by, or the other way around, x1 by h, therefore, must be equal to y1 by k, a square b squared get cancelled, and must be equal to 1 by h squared by a squared plus k squared by b squared. right? So then x1 turns out to be h by h squared by a squared plus k squared by b squared. Y1 must be k by h squared by a squared plus k squared by b squared. Hey, x1 y1 is a point on the director circle. So x1 squared plus y1 squared would be a squared plus b squared, right? So to eliminate x1 y1, say x1 squared plus y1 squared is a squared plus b squared. Why is it a point on the director circle? Because the two tangents are perpendicular to each other, drawn from P, right? So x1 squared plus y1 squared is this, which is like h squared by equal to 1. And then you generalize this. Replace h by x and k by y. In this, you will get the locus of M, the midpoint of AB. Locus of M, the midpoint of AB, which is the circumcenter of the variable triangle AQB. Circumcenter of the variable triangle AQB. Are you confused? Oh, I'm sorry, equal to a square plus b square. I'm so sorry. A square plus b square. Right. Precisely. Equal to a square plus b square. Shall I proceed? For the ellipse, this is the ellipse, x squared by a squared plus y squared by b squared equal to 1, a greater than b. Find the locus of the centroid of the triangle formed by the center and the points of intersection of the chord of the ellipse that subtends a right angle at the origin. So we are seeking very many chords AB that subtend a right angle at the origin. That subtend a right angle at the origin. That is the center of the ellipse in this case. Now, first of all, look at this triangle AOB. What are we seeking? We are seeking the centroid. We are seeking the centroid. This is a right angle triangle. The midpoint of the hypotenuse, will be the circumcenter of the triangle, O will be what? O will be the orthocenter. Intersection of two perpendiculars from opposite vertices will be the orthocenter of the triangle. The orthocenter of a right angle triangle will be the right angle vertex, right? So this is the orthocenter. In a triangle, the centroid lies on the line joining the orthocenter to the circumcenter. The centroid will lie on the line joining the orthocenter to the circumcenter and will divide it in the ratio 2:1. The centroid divides the line joining the orthocenter to the circumcenter in the ratio 2:1. In the ratio 2:1. Yes, sir. Okay. This is 0, 0. Suppose the centroid is h, k. What we are seeking is What we are seeking is the locus of the centroid. That means an algebraic relationship connecting h and k, and then we go on to generalize that, replace h by x and k by y. That will give me the locus of the centroid. Now, again, either use section formula or just common sense. This is 0, 0 to this line. Realize that this length is to this length is 3:2, right? So then coordinates of m would be 3h by 2 comma 3k by 2. These would be the coordinates of m. Section formula, or if you don't like this, what you can do is x coordinate of m into 2, right? Plus 1 into 0 divided by 3, that will be h. Yes or no? You can use section formula. 1 into 0 plus 2 into the x coordinate of m divided by 3 will be h. So you know the x coordinate of m, although that's not required. You can just use external section formula to arrive at the coordinates of, m divides OG externally in this ratio, or you can, either way you feel comfortable. But I hope all of you will be able to arrive at the coordinates of m using section formula one way or the other. Yes or no? No? Now, the equation of AB can be written, in terms of its midpoint m. T equal to S1 is the equation of AB in terms of its midpoint, right? Midpoint is 3h by 2 comma 3k by 2. T equal to S1 means T equal to S1. That's the equation of the chord in terms of its midpoint, right? Which, if you want, you could also write as by a squared plus y into 3k by 2 by b squared whole divided by 3h by 2 whole squared by a squared plus 3k by 2 whole squared by b squared equal to 1. That's the equation of the chord AB, the variable chord AB. That subtensor right angle at the origin. Right? This by this equal to 1. Now, how do I get the combined equation OA and OB? Yes, if I have this ellipse and if I homogenize this ellipse with this line is given as that. If I homogenize this ellipse with the help of this line, then I get pairs of straight lines passing through A and B and the origin. That means the lines OA and OB would be obtained if I homogenize the ellipse with this line, right? That's what happens. How do I homogenize the ellipse with this line? I can homogenize the ellipse with this line. This is the equation of the ellipse. I don't touch these second degree terms. This one I replace by this square. This one I replace by this square. Yes or no? So homogenize the ellipse with the line to get the pairs of straight lines passing through the origin. X square by a square plus y square by b square equal to, instead of 1 I write this square. Yes or no? Right? Which you can write as x square by a square plus y square by b square into 3h by 2 whole square by a square plus 3k by 2 whole square by b square whole square, right, equal to x into 3h by 2 whole square by a square plus y into 3k by 2 y, I'm sorry, by b square whole square. Clear? Essentially, what would you get out of this without adding dirt? This will give you what? Pairs of straight lines passing through the origin, that means the lines OA and OB. It will give you the combined equation of OA and OB. This will be essentially, when I consolidate terms here, what would I get? I would get terms of the following kind. Something into x square plus something into xy plus something into y square equal to 0 is what I'll get, which is the combined equation of OA and OB. These would be the format of the terms. There will be x square terms, there will be y square terms, and there will be a xy term. That's all, right? There would be no other term, which is a homogeneous second degree equation in x and y representing pairs of straight lines OA and OB. Now, if the pairs of lines OA and OB are perpendicular to each other, that would happen if the coefficient of x square is negative of the coefficient of y square. So all that you need to do is, whatever coefficient of x square that you get from here, put that equal to negative of the coefficient of y squared, and then generalize. Replace h by x and k by y. That will give you the locus of the required centroid of the variable triangle AOB. Clear? So far so good. Shall we proceed? This is an ellipse. X square by a square plus y square by b square equal to 1. Prove that the straight lines joining the center of the ellipse to the points of intersection of the line. This is a line which is like y, I can write it as y minus mx by root a squared m squared plus b squared by 2. This is a line. This is equal to 1. Intersecting the ellipse at a and b. What we got to show is that if I join A to O and I join B to O, then AO and BO would be pair of conjugate diameters. AO and BO would be pair of conjugate diameters. When would AO and BO be pairs of conjugate diameters? If the product of their slopes is minus B squared by A square. Now, how do I get the combined equation of AO and OB? If I homogenize the ellipse with the line. If I homogenize this ellipse with the line, then I get the pairs of straight lines OA and OB. So then OA and OB homogenize ellipse with AB and equal to 1. 1 to be replaced by this squared. 1 to be replaced by this squared. right? Now, if I collect terms here, what would I get? 1 by a squared minus 2m squared by a squared m squared plus b squared plus 2xym into 2, so 4. Does not matter though, this term, by a squared m squared plus b squared plus y squared into 1 by b squared minus 2 by a squared m squared plus b squared equal to 0. Right, that's what I get. Hey, if I have a line of the form ax squared plus 2hxy plus by squared equal to 0, then on dividing by x squared, I get like a b into y by x whole square plus 2h into y by x plus a equal to 0. The product of the slopes of these two lines is a by b, coefficient of x squared divided by coefficient of y squared will give me the product of the slopes of these lines, right? Isn't it? I've done that before. Pairs of straight lines passing through the origin. I'm just repeating that. So coefficient of x squared divided by coefficient of y squared. So then this was pairs of straight lines passing through the origin, passing through this O, and the product of the slopes of these two lines, AO and OB, is going to be M1, M2 is coefficient of x squared divided by coefficient of y squared. Now see, it's no tall order simplifying this. See, a squared m squared, you will simply have a minus sign, and this b squared would go up, this a squared would come down, this will get cancelled with this, and there will be a minus when you say this minus this. This will simply give you a minus b squared by a squared. This should give you a minus b squared by a squared. And if the product of these slopes is minus b squared by a squared, then AO and BO must be conjugate diameters. Conjugate diameters. Shall I proceed? This is an ellipse. X squared by a squared plus y squared by b squared equal to 1. A circle is inscribed in an ellipse, and the eccentricity of this ellipse, e squared, is 1 by root 2. That's the eccentricity of this ellipse. E is 1 by root 2. So b squared is a squared into half. So b squared by a squared, essentially b by a, would be 1 by root 2. Because b squared is a squared into 1 minus e squared. 1 minus e squared means 1 minus half. So half. B squared is a squared into 1 minus e squared, right? So b by a is 1 by root 2. I hope all of you remember all of this. This is an ellipse, and there is a circle inscribed inside the ellipse, having a common center with the ellipse, Suppose the circle is x squared plus y squared equal to r squared. Tangent set P on the ellipse. So I select very many points on the circle, and I draw tangents at those points. P is a variable point on the circle, and I draw a tangent at this point. It intersects the ellipse at A and B. Find the locus of the points of intersection of the tangents at A and B on the ellipse. Okay. So now again at A and B, I draw tangents to the ellipse. And these tangents intersect at P. I want to find the locus of, let me call it Q, because if this point is P, let me call this Q. I want to find the locus of Q. So very clearly, for different P's, I'll have different ABs, and different ABs will produce different Q's. So there is a locus associated with Q. We want to show that the locus of Q is an ellipse, and we then want to be able to find the eccentricity of the ellipse produced out of the movement of Q for different P's. So let's say H can be any point on the locus of Q. Then the equation of AB is the chord of contact with respect to Q. AB is the chord of contact with respect to Q. So equation of AB is like a hx by A square plus ky by B square equal to 1. T equal to 0 is the chord of contact. T equal to 0. And realize that the perpendicular distance of this line from the origin must be equal to the radius of the circle, right? The perpendicular distance from the origin to this tangent must be equal to the radius. This is the tangent. Its distance from 0, 0. Its distance from 0, 0 is what? Put x equal to 0, y equal to 0. Take the modulus 1 divided by root h squared by a to power 4 plus k squared by a to power 4. That must be equal to the radius. That must be equal to the radius. Right? That must be equal to the radius owing to tangency, which should mean h squared by a to power 4 plus a squared by b to power 4 is 1 by r squared. This equal to 1. Perpendicular distance of 0, 0 from this line. How do you obtain the perpendicular distance of 0, 0 from this line? Put x equal to 0, y equal to 0. So 1 divided by root coefficient of x squared, which is this, coefficient of y squared, which is this. That's how you get the perpendicular distance of a point from a line, which I can jolly well write as h squared by a squared by r whole square plus k squared by b squared by r whole square equal to 1. Which is what? If I replace h by x and k by y, x squared by a squared by r whole square plus y squared by b squared by r whole square equal to 1. It represents a ellipse. The locus of Q therefore is an ellipse. What's the eccentricity of the ellipse formed out of the various Q's? 1 minus this by this whole square. That means 1 minus this by this essentially. This by this is b by a whole to power 4. b by a whole to power 4. b by a whole to power 4 would be 1/4. Would be 1/4, right? 3 by 4. Eccentricity of the ellipse formed out of various Q's is root 3 by 2. The eccentricity of the ellipse formed by various Q's is root 3 by 2. Is it okay? A variable point P on the ellipse of eccentricity E is joined to the focus S and S prime. Let's say this variable point is x1 comma y1. AE0 minus AE0. One focus, the other focus is AE0. We want to be able to find the locus of the in-center of triangle PSS prime. You want to find the locus of the incenter of this triangle PSS prime. I mean, obviously, if you select different points, you'll have different triangles PSS prime. And for each of these PSS primes, there would be a different incenter. So there would be a locus associated with the incenter of the triangle PSS prime. Now, distance of x1, y1 from this focus, we already know is a minus ex1. Right? No, this I told you this, no? Distance of x1, y1 from this focus is a plus ex1, right? And this is 2ae. This is 2ae. Now the incenter has coordinates say h comma k. Do you remember the result for the coordinates of the incenter? ax1 plus bx2 plus cx3 by a plus b plus c. Y coordinate is by1 plus cy2 plus by2 plus cy3 by a plus b plus c, which means the x coordinate of the incenter h is given by x1 into 2ae plus a plus ex1 into ae into a plus ex1 then minus ae into a minus divided by a plus b plus c, sum of the sides of the lengths of the sides. This plus this is 2a, 2a plus 2ae is 2a into 1 plus 2a into 1 plus e. That would be the x coordinate of the incenter of the variable triangle, right? This, as you can very easily see, is, see in this AEA and minus AEA would get cancelled, right? And then we have AE into EX1 plus AE into EX1, that's 2AE into EX1, right? So 2AE x1 if I took common, I get within the parenthesis 1 plus E divided by 2A into 1 plus E, right? This is what I get. So 2A into 1 plus E gets cancelled. So that's like a EX1. That's like a EX1. The x coordinate of the incenter is EX1. Y coordinate of the incenter K, again, Y1 into 2AE plus 0 into this length plus 0 into this length divided by the sum of the lengths. Right? So this gives me y1 equal to k into 1 plus e by e, that's y1. And x1 I get as h by e. x1 I get as h by e. I have to connect h and k, right? I need to connect h and k. To get the required locus of the incenter, I need to connect h and k. See, but what is x1 y1? It's a point on the ellipse. So x1 squared by a squared plus y1 squared by b squared equal to 1. So if I use x1 squared by a squared plus y1 squared by b squared equal to 1, x squared by a squared e squared y1 squared is k squared by b squared e squared by 1 plus e whole square equal to 1. x1 squared by a squared plus y1 squared by b squared equal to 1 will give me this, where x1 y1 are these. Now, so one thing for sure, I can replace h by x and k by y. That will give me the locus of the incenter. So if I replace h by x and k by y, I get the locus of the incenter. And what is this? And it's an ellipse. It's an ellipse, right? And the eccentricity of this ellipse, the eccentricity of the ellipse is EI. EI squared is eccentricity of the ellipse formed by the incenter. Eccentricity of the ellipse formed by the incenter would be 1 minus this divided by this. Right. But b squared by a squared, realize that the original ellipse had eccentricity e, such that e squared is 1 minus b squared by a squared. In fact, b squared by a squared was 1 minus e squared. E is the eccentricity of the original ellipse, right? So this b squared by a squared I replace by 1 minus e squared whole square, which is 1 minus e by 1 plus e, which is 2e by 1 plus e. So the eccentricity of the ellipse formed out of the incenters is going to be root 2e by 1 plus e. Got me? This is a quadrilateral. ABCD, and these are the two diagonals of the quadrilateral. These are the two diagonals of the quadrilateral. The two diagonals intersect at the point P. One ellipse is drawn with A and B as foci and passing through P, and another ellipse is drawn with C and D as the two foci and passing through. We got to show the two ellipses touch each other at P. See, one ellipse passing through P and having A and B as the foci would be like this. The other ellipse passing through P and having C and D as its foci would be like this. These would be the two ellipses, right? Now, when would they touch each other? They would touch each other if they have a common tangent. Then they would be touching each other. Having a common tangent is like having a common normal. It's like having a common normal. If they have a common normal at the point where they intersect, if they have a common normal at the point where they intersect, they would have a common tangent. In which case, they would touch each other. In which case, they would touch each other at the point P. Refer to this as ellipse 1. Refer to this as ellipse 2. Ellipse 1 has A and B as its foci and it passes through. For ellipse 1, imagine a ray of light starting from A, hitting the ellipse at P, then after reflection, it must pass through the other focus B. Yes or no? That's a property of ellipse. If I draw an angle bisector at P, then this is the angle of incidence, this is the angle of reflection. So the angle bisector would be the normal to ellipse 1 at P. The angle bisector would be the normal to ellipse 1 at P, yes or no? The angle bisector at P would be the normal to the ellipse at P. Is that okay? This is an ellipse. This is the normal at the point of incidence. This is the one focus, this is the other focus. Then this angle is theta, this angle is theta. So normal at the point of incidence, angle of incidence equal to angle of reflection. Right? So this angle bisector would be the norm, the log of reflection. So this is normal to ellipse 1 at the point P. This is the normal to ellipse 1 at the point P. Clear? Now come to ellipse 2. For ellipse 2, if you imagine a ray of light to start from C, and if it passes through P, then after reflection, it will go past D. Here the focus, right? Now, evidently, vertically opposite angles, these are also equal, theta and theta. So, which means this line is also a normal to the second ellipse, is also a normal to the second ellipse. That means, but N1 and N2 are the same line. That means both the ellipses have a common normal. Both the ellipses have a common normal. If they have a common normal, then they have a common tangent. And if they have a common tangent, they must be touching each other. They have a common normal. This is their common normal at the point P. The angle bisector at the point P. So they must touch each other at the point P. This is an ellipse. Major axis of the ellipse. This is the directrix. And a tangent is drawn at a certain point. And a tangent is drawn at a certain point P of the ellipse. This tangent makes an angle alpha with the major axis. I mean, we will assume that alpha is acute. It makes an acute angle alpha with the major axis. That means, it makes, and this is a line parallel to the major axis. This is a line parallel to the major axis. And the tangent makes an angle alpha with any line parallel to the major axis. This is a line parallel to the major axis. And an angle beta with the focal radius. This is the focus. So this angle is theta. This angle is beta. Now, do you recall this property? What angle will PT subtend at the focus? 90 degrees. Do you remember this? Portion of the tangent lying between P and the directrix will subtend a right angle at the focus. So this is 90 degrees. Hey. Suppose this is M. SP is E times PM. Right? So E is SP by PM. E is SP by PM. Clear? Hey, this right angle triangle. Do you realize that PM is PT cos alpha? PM is PT cos alpha. And SP is PT cos beta. This again is a right angle triangle. So SP would be PT cos beta. I'm sorry. I'm sorry. SP is this, so PT cos beta. So sorry about this. And this is PT cos alpha. I'm so sorry about this. SP is PT cos beta and PM would be PT cos alpha. So cos beta by cos alpha. That's the eccentricity of the ellipse. It's eccentricity. Ellipse x squared by a squared plus y squared by b squared equal to 1. That's the ellipse. Tangents are drawn at right angles to the ellipse. These are tangents. drawn from P, HK, right angles to the ellipse. That means these P's lie on the director circle. So h squared plus k squared is a squared plus b squared. Find the locus of the middle point of the chords of contact, various chords of contact. M, x1, y1 is the midpoint of a certain chord of contact. What's the equation of AB? T equal to 0. I want to find the locus of M. I want to find the locus of AB could be looked upon as number 1, xx1 by a squared plus yy1 by b squared equals t equal to s1, x1 squared by a squared plus y1 squared by b squared, t equal to s1. Equation of a chord in terms of its midpoint, t equal to s1, right? So I can also look upon AB as the chord of contact with respect to hk. So then AB is t equal to 0. AB then would be t equal to 0. T equal to 0 is like hx by a squared plus ay by b squared equal to 1. But both these equations represent the same line, so their coefficients must be proportional. That means h by a squared by x1 by a squared must be k by b squared by y1 by b squared must be 1 divided by this, right? So h by x1 then turns out to be k by y1 must be 1 by x1 squared by a squared plus y1 squared by b squared, and therefore h turns out to be x1 squared by a squared plus y1 squared by b squared. Then all that you need to do is you need to say h squared plus k squared is a squared plus b squared. Hk gets eliminated that way. This square plus this square will be a square plus b squared. Replace x1 by x and y1 by y to get the locus of the midpoint, and to get the locus of the midpoint, now if this is the focus f, which is AE0, then the end of the lattice rectum is going to be AE comma b squared by a, right? The end of the lattice rectum is going to be AE comma b squared by a. This will be AE comma minus b squared by a. The tangent drawn at the end of the lattice rectum, xx1 by a squared plus yy1 by b squared equal to 1. So the tangent drawn is going to be xx1 by a squared plus yy1 by b squared equal to 1. So we get like a ex plus y equal to 1. We get ex plus y equal to 1. That's the equation of this tangent. Ex plus y equal to 1. Now, MP is the ordinate of a certain point P. Let's say P has coordinates x1 comma y1. P has coordinates x1 comma y1. MP is the ordinate of a certain point P. MP is y1. MP is y1, right? Now, if I reduce it, it intersects the tangent at R. It intersects the tangent at R. But what's the equation of this tangent? This tangent is Ex plus y equal to 1. So for R, y is y1. I'm sorry. For R, x is x1, right? R of x and R of p is x1. So for R, x is x1. So for R, x is x1. So y of R would be 1 minus ex1. Y of R would be 1 minus ex1. This should be A actually. This should be A. Ex plus y equal to A. So A minus ex1 going to be A minus ex1 for R, right? And then what is MR? MR is the y A minus ex1. A minus ex1. And what's FP? Distance of a point from the focus AE comma 0 would be A minus EX1. So far so good. So we have a regular ellipse, x squared by a squared plus y squared by b squared equal to 1. And there is a chord which is drawn between 2 points with eccentric angles alpha and beta. This is the center C, and it cuts the major axis at a distance d, that means let's say at d0. Then I want to show that tan alpha by 2 into tan beta by 2 is d minus a by d plus a. Very simple. Equation of the chord joining alpha and beta is going to be x by a cos alpha plus beta by 2 plus y by b sin by 2 equal to, right. Now this chord passes through d comma 0, so put x equal to d, y equal to 0. So then that's d by a cos alpha plus beta by 2 equals cos alpha minus beta by 2. All that you need to do now is componendo dividendo. D by a equals cos alpha minus beta by 2 by cos alpha by plus beta by 2. Apply componendo dividendo, d plus a by d minus a, etc., and you will get the required result, right? Are you alright with this? Can I add this on? So we have P a parameter, real parameter, such that 2px plus y root 1 minus p square equal to 1 for all values of p touches a certain curve. We need to find the curve. This line, for different values of p you will get different lines. It said that this is a tangent to a certain curve. You have to find that curve. And I have told you what to do here. Do you remember the concept of enveloping curves? Right, very good. Right. So what you could do is y root 1 minus p squared whole squared is 1 minus 2px whole squared, right? So this is like a y squared into 1 minus p squared, which would then offer to give me a quadratic in p. So then I have 4x squared plus y squared into p squared minus 4x into p plus 1 minus y squared equal to 0, which is a quadratic in the parameter p. To get the enveloping curve, all that you need to do is discriminant equal to 0. Put discriminant equal to 0. So if you put discriminant equal to 0, 4x whole squared is 4 times 1 minus y squared into 4x squared plus y squared. If you simplify this, you will get the equation of the ellipse which it touches. You will get the required ellipse if you simplify matters here, right? Can I write this off? So these are x and y axis, and this ellipse is rolling without slipping on the two axes. It's actually rolling without slipping on the two axes. That's what it's doing. I need to find the locus of focus. I need to find the locus of the focus, right? Simply speaking, well, even if it rolls, its eccentricity is not going to change. Its major and minor axis will remain the same. These are fundamentals. They won't change if you reorient the ellipse or you take it to a satellite, right? It's going to remain the same. Now, let's say this focus is h comma k. This focus is h comma k. All right. Let me just draw a little better view so that you know. This is one focus S, which is h comma k, right? And this is the other focus S prime. Do you realize that the x-axis is a tangent to the ellipse, right? And these are perpendiculars from the two foci. So this length, which is k, into this length, which is something, must be equal to b squared. Yes or no? So this length must be b squared by k. Yes or no? If this length is k, then the product of these two perpendiculars on any tangent would be a constant and equal to b squared. Have I given you this property? Piyush, right? Okay. Now this length is h. Again, this length, these are two perpendiculars on the y-axis. This length into this length will also be b squared. So if this length is h, this would be b squared by h. Which means the coordinates of S prime would be b squared by h comma b squared by k would be the coordinates of the other focus. If one is h comma k, the other one would be b squared by h and b squared by k. Now, very clearly, if a and b are the semi-major and the semi-minor axis, then the eccentricity of the ellipse would be 1 minus b squared by a squared. And the distance between the two foci would always be 2ae. It's going to be 2ae. Now the distance between the two foci, square of the distance between the two foci would be h minus distance formula by h whole square plus k minus b squared by k whole square equals 4a squared e squared. Which is like 4a squared into 1 minus b squared by a squared, which is like 4 times a squared minus b squared. That's all of this. And then you have a relationship between h and k, the x coordinate h and the y coordinate k of the focus. Yes or no? All that you need to do is replace h by x and k by y. You will get the locus of. Yes or no? Right? Got me? Replace h by x and k by y, and this would be the locus of the focus. Are you all right with this? I will leave it to your judgment to how to find now the locus of the center. Right? It would be a lot easier than this, right? Can I wipe this off? Huh? Also want to tell you that both the foci have the same locus here. Because if that was h comma k, then this would have been b squared by h comma b squared by k, and the distance formula will give me the same locus. When you square, then it's going to be the same. If they have the same locus, why are they at different points? Well, it's all right. They pursue the same path, but they arrive at the same point at a phase lag. There is a phase lag between their arrivals. That's all. But the same path is followed by both. Right? If the ellipse rolls without slipping on the two axes, right? So now this is an ellipse. Call it x squared by a squared plus y squared by b squared equal to 1. This is the ellipse x squared by a squared plus y squared by b squared equal to 1. And if you recall, if this is a circle, let's say alpha, beta, gamma, delta, alpha, beta, gamma, delta, right? Then these are 4 concyclic points. Then the x coordinate of the center of the circle, x coordinate of the center of the circle is going to be what? X coordinate is going to be a squared minus b squared by 4a into cos gamma plus cos delta, right? And the y coordinate of the center is now the sine. Same thing, sine alpha plus sine beta plus sine gamma plus sine delta. That's the y coordinate of it. Yes or no? You know this? Now we have a special situation here. In this situation, the circle passes through the ends of a diameter. Let's say, which means, let's say alpha, beta, I'm sorry it's a disproportionately drawn figure, but let's say if this is the diameter, right? If this is the diameter, then if this is alpha, then beta would be alpha plus pi, right? Beta, if this is a diameter, then beta would be alpha plus pi, yes or no? Also, if it touches the circle, then gamma and delta must coincide. If gamma becomes equal to delta, then the circle also touches the ellipse. If, right, isn't it? If two points of intersection converge into one, then that creates tangency of the two curves. Yes or no? Right? So this circle will touch the ellipse if gamma and delta coalesced into one. That means if gamma equals delta, then the condition for circle touching the ellipse arises. Circle touching the ellipse arises. Right? Okay. Now, with this data, let's look at the x coordinate once again. A squared minus b squared by 4a. Beta would be alpha plus pi. So cos alpha and cos alpha plus pi would be 0. And gamma equals delta. So this will become 2 cos gamma. This will become 2 cos gamma. Yes or no? Right? For touching, this will become 2 cos gamma. Okay. Come back to this. Beta is alpha plus pi. So sin alpha plus pi plus sin alpha will be 0. Right? And gamma becomes equal to delta. So this will become 2 sin gamma. This will become 2 sin gamma. So the y coordinate is b squared minus a squared by 4. I do not know why I am getting blank looks. Have I discussed this result in the class? Right? 2 sin gamma. Right? Now I need to eliminate gamma to connect x and y. What do I need to do? Square and add. Square and add. X square plus y, or rather 4ax and 4by, and then square and add. 4ax will be this, 4by will be this. Then when you square and add, you get a squared minus b squared into 4 cos square gamma plus sin square gamma. That would be, see, bring it here, 4ax equal to this and 4by equal to this. Then 4ax whole squared plus 4by whole squared is a square minus b squared into 4 cos square gamma plus 4 cos sin square gamma. That's 4. How about it? Got me? That will give you the locus of the center of such a circle. All circles enjoying this property. Right? Can I wipe this off? There is a point P on this ellipse, call it A cos theta, B sin theta. Now, there is a parabola that's drawn. The parabola is drawn in a manner that it passes through the two foci S and S prime. It passes through the two foci S and S prime. and a certain point on the ellipse a cos theta b sin theta is its focus. That's the focus of the parabola. Actually, two such parabolas could be drawn. If you really look at it, I could have had a parabola like this also, with P being the focus and passing through S prime, and there are essentially two orientations of the parabola having their foci both at P and passing through the foci of the ellipse S and S, right? Now, we want to show that the angle between the directrices of the two parabolas, is 2 theta. Is 2 theta. That's what we want to show. Theta is the eccentric angle of the point P. There is a directrix for this. There is a directrix for this parabola, and there is a directrix for this parabola. We want to show that these two directrices enclose an angle 2 theta, which is twice the eccentric angle of P, Yes or no? Now, let me look at one. In fact, we could arrive at the result for both by just looking at one. Let me look at this parabola, for example, and say x cos alpha plus y sin alpha equals P is this directrix. Now, this directrix could also be written as P minus x cos alpha minus y sin alpha equal to 0. That's also this directrix. And let me assume, for definiteness, it will result in no loss of generality. Let me assume that all points on this side of this directrix will give me a positive value for this expression. Can I assume that? No loss, because if this doesn't, then this will, right? So, let me say all points on this side of the directrix will give me a positive value for this expression, only out of definiteness. Do you realize that this distance is a into 1 plus e cos theta, and this distance is going to be a into 1 minus e cos theta? So, this is a into 1 minus e cos theta, and this is a into 1 plus e cos theta. Yes or no? Distance of the two foci from a point P given by theta, a minus ex1 and a plus ex1. Yes or no? A minus ex1 and a plus ex1, right? Now, S prime is a point on the parabola and P is its focus. For the parabola, forget the ellipse now, for the parabola now. S prime is a point on the parabola and P is its focus. Do you realize that the distance of S prime from the directrix will be equal to distance of S prime from the focus? Distance of S prime from the directrix will be equal to distance of S prime from the focus. That's how a parabola is constructed. So, if this is a into 1 plus e cos theta, this will also be a into 1 plus e cos theta. Yes or no? Right? Okay, again, this is a point on the parabola once again, and its distance from the focus will be its distance from the directrix. So, which means if this is a into 1 minus cos theta, what would this be? A into 1 minus e cos theta. Yes or no? Does it make sense to you? Okay. Hey, this is the directrix and this is the perpendicular distance of AE from the directrix. Now, how do you find the distance of AE from this? Put x equal to AE, y equal to 0, and divide by root cos square alpha plus sin square alpha, yes or no, right? This distance, which from a secondary consideration has turned out to be a into 1 minus e cos theta, is also the distance of AE from this line. Put x equal to AE, y equal to 0. So that's P minus AE divided by root cos square alpha plus sin square alpha, yes or no? Why I didn't put the modulus sign? Because AE, when plugged into this, AE comma 0 will give me a positive value. All points I have assumed on this side of the directrix are giving me positive values for this expression, right? Yes or no? Okay. Now distance of minus AE from this is A into 1 plus E cos theta. Does it make sense to you or not? Oh, I'm sorry. AE cos alpha. Alright. Distance from this directrix is A into 1 plus E cos theta, which is the distance of minus AE from this, and the distance of minus AE from this line. Plug in x equal to minus AE, y equal to 0, divide by root cos square alpha plus sin square alpha. That will give me P plus AE cos alpha. Yes or no? That will give me P plus AE cos alpha. Does that make sense to you? I subtract. So I get 2AE cos alpha is 2AE cos theta. Yes or no? If I subtract this minus this, then I get 2AE cos alpha is 2AE cos theta, right? When I subtract this minus this, 2AE cos alpha is 2AE cos theta. Or cos alpha is cos theta. Yes or no? Cos alpha is cos theta, which means alpha could either be plus theta or minus. Alpha could either be plus theta or minus theta. Alpha equal to plus theta will give me one of the directrices. Alpha equal to minus theta will give me the other directrix for the other orientation of the parabola. Does it sound alright? Right? So the alpha that we were seeking for the directrix could either be plus theta or it could be minus theta. So if I plug in alpha equal to plus theta, I will get one of the directrices. If I plug in alpha equal to minus theta, I will get the other directrix. Does it sound alright? Now, once we have this in place, can I remove this clutter and do the last bit on this problem? Look, when I write a line like x cos alpha plus y sin alpha equal to p, then what is implied? Look, if this is the x-axis, the y-axis, then what it means is that from O, if you draw a perpendicular, the perpendicular would be of length p, and the perpendicular would enclose an angle alpha with the x-axis. That's what it means. Then this line would be x cos alpha plus y sin alpha equal to p, right? So now, for the two lines, for the two directrices, realize that this is the origin, and if these were the two directrices, d1 and d2, then this would be one of the directrices corresponding to alpha, and this would be the other directrix corresponding to actually minus alpha, because in the opposite sense. Yes or no? Right? Right? So let's say both equal in magnitude to theta, both equal in magnitude to theta. This is alpha equal to plus theta, this is alpha equal to minus theta, right? These are the two directrices then, right? These are the two perpendiculars. This is a cyclic quadrilateral. This is a cyclic quadrilateral. So if this angle is 2 theta, this must be pi minus 2 theta, and this angle therefore would be 2 theta. So the angle between the two directrices is 2 theta. twice the eccentric angle of the point P. Twice the eccentric angle of the point P. Yes or no? Right? Which is what we set out. Ellipse x squared by 2a squared plus y squared by 2b squared equal to 1 is the ellipse. Now x plus y equal to b is a certain line. We want to be able to show this is the ellipse. If this is the ellipse, then we want to be able to show that two distinct chords, or we want to be able to find the condition so that two distinct chords are bisected by x plus y equal to b, given that the chords pass through a comma minus b. Given that the chords pass through a comma minus b, two distinct chords could be drawn that are bisected by x plus y equal to b. Which means any point on x plus y equal to b is like x equal to h, y equal to b minus h. Yes or no? So if I select points of the form h comma b minus h, then these points are forced to lie on this line by their very choice of selection. H comma b minus h for any value of h will be a point on, right? Now I want to be able to draw a chord. In fact, I want to be able to draw a chord whose midpoint is m h comma b minus h, I want to be able to draw a chord whose midpoint lies on this line. In fact, I want to be able to draw chords. That means two values of h must exist such that this is the midpoint. Two values of h will produce 2 points m, each lying on this line and still being the midpoint, right? Now, can I write the equation of the chord in terms of the midpoint? G equal to S1 would be the equation of the chord in terms of the, which is going to be x into h by 2a squared plus y into b minus h by 2b squared is x squared by 2a squared t equal to S1 plus b minus h whole squared by 2b squared. Yes or no? But this will pass through a comma minus b. This is known to pass through. Both these chords will pass through a comma minus b. So put x equal to a and y equal to b. Now what I existence of two values of h will cause existence of two chords with midpoint being of the form h comma b minus h. Two distinct values of h will cause existence of 2 points of the form h comma b minus h, both being the midpoint of two chords, and this midpoint by its very choice will lie on the line x plus y equal to b, right? So all that you need to do is this solve for h should give me two distinct values of h, If you rewrite this as something into h squared plus something into h plus something equal to 0, which is a quadratic in h, all that you need to do here is put discriminant greater than 0. Discriminant greater than 0 would give you the desired condition. Discriminant greater than 0 will give you distinct values of h of 2 points, two midpoints, each of the form h comma b minus, and therefore existence of two chords whose midpoints lie on the line x plus y equal to b. This is all that you need to do. A number of ellipses are described having the same major axis but a variable minor axis. Let's say this is the major axis, this is the directrix, this is the directrix. Say this is a focus S, which is some c comma 0. I can choose to call the major axis the x-axis. Who stops me from doing that? This would be of the form some c comma 0, and then the directrix, which would be, let's say, x equal to a, would be the right. In fact, I don't even need to write it in this form. I can just write it in the regular form, which is x square by a square plus y squared by b squared equal to 1 is the regular ellipse, which I can write, and the ends of the lateral vector would be plus minus ae comma plus minus b squared by a. There would be 4 ends, right? 2 lateral vector, 4 ends, all combinations permissible. ae comma plus this, ae comma minus this, minus ae comma plus this, minus ae comma minus b squared. These would give me the 4 points, right? In this case, a is a constant but b is a variable. A is a constant but b is a variable. So if a is a constant and b is a variable, then the equation of the tangent is going to be given by x plus minus ae, all the tangents, by x1 plus y plus minus b squared by a by b squared equals 1. Yes or no? That would be the equation of all the 4 tangents. By all 4 combinations, you will get 4 tangents at the ends of the lateral vector. Very clearly, this will give me plus minus ex plus minus y equals a. A is a constant but b is a variable. E is a constant but b is a variable. Can you see readily that this will always pass through a certain point? What point is that? 0 comma plus minus a. 0 comma plus minus a. 0 comma plus minus a will be a point through which it will always pass, right? 0 comma plus minus a. The MCQs starting from problem 18, 16, all right. So what we have is, in problem 16, an ellipse with B as the end of a minor axis and S and S prime the 2 foci, and the angle SBS prime is a right angle. SBS prime is a right angle. That's given in the problem. Right? Which means this angle is 45 degrees, this angle is 45 degrees. See, SBS prime. So this, since S and S prime are symmetrically located, so this is 45 degrees on either side, right? We need to find the eccentricity of the ellipse. So this is the semi-minor axis. This is AE. A is the semi-major, E is the eccentricity of the ellipse. And if this is 45 degrees, realize that AE will be equal to B. So B is AE or b squared by a squared is e squared, but b squared by a squared is also 1 minus e squared. So that gives me e equal to 1 by root 2. E equal to 1 by root 2, the eccentricity. And I'm hoping you got it right on your own as well, right? Now, problem 17. There is an ellipse which is like x squared plus 2y squared equal to 2, which is to say that x squared by 2 plus y squared by 1 equal to 1. That's the ellipse. A squared is 2, b squared is 1 here. And normals are drawn to the ellipse from the point 2, 3. Then the co-normal points on the curve. Okay, let's say from the point P, which is 2, 3, we are drawing normals. We are drawing normals at h, k, let's say. We are drawing normals at h, k. In general, they would be 4 hk's, right? From the point P, they would be in general 4 hk's, right? We need to connect h and k. These hk's would be the co-normal points. The locus of the 4 co-normal points would be obtained when I connect h and k and then generalize the same. Replace h by x and k by y. Alright. Now, the normal at h, k, is given by x by h by a squared minus y by k by b squared equals a squared minus b squared. X by x1 by a squared minus y by y1 by b squared is a squared minus b squared. The equation of the normal at h, k is this, right? Hey, but this normal passes through 2, 3. So 2, 3 will satisfy this equation. So plugging in x equal to 2 and y equal to 3 here, we get equal to 1, or we have 4k minus 3h minus hk as 0, and then generalize this, replace h by x and k by y. So 4y minus 3x minus xy equal to 0 is the locus of the 4 co-normal points. All the 4 co-normal points lie on this curve. The 4 co-normal points lie on this curve, which is like 3x minus 4y plus xy. So that's option B. Option B. Option B. A series of ellipses are described with a given focus and a corresponding directrix. Given focus, let me call this, I can call the focus the origin. Who stops me from doing that, right? And a given directrix. The locus of the extremities of the minor axis. Okay. Now, if C is the center, and let's say this is the x-axis, then the center would be minus AE0. The center would be minus AE0 because this distance is AE. A is the semi-major axis, E is the eccentricity of the ellipse. So this would be minus AE. Then the end of the minor axis would lie here with x being minus AE and y being B. Yes or no? Now we need to connect x and y. That would be the required locus. Now what's the parameter here? E is the parameter here, right? With different eccentricities that's given in the problem. So we need to find the locus of B connecting x and y by eliminating E, right? Now, as long as the focus and the directrix is fixed, this distance will remain fixed. This distance is A by E minus AE. This distance physically will always be A by E minus AE. That's a constant. So A by E minus AE is constant. Right? Or you have A into 1 minus E squared by E equal to a constant. Hey, but 1 minus E squared is B squared by A squared. Is B squared by A squared. So this becomes B squared by A squared. So it will become like a B squared by AE equal to a constant. Yes or no? Hey, B is the y coordinate of the end of the minor axis. So this is y squared. So you have y squared by, and minus AE. AE is negative of the x coordinate of the, so minus x, that's a constant, right? So we have y squared equal to minus a constant into x, which represents what? A parabola. So the locus of B is a parabola given by y squared equal to minus constant into So with this as the focus and this as the directrix, if you continue to draw ellipses of different eccentricities, then the path traced by B will be a parabola, right? (19) Tangents are drawn from the point 3, 4 to the ellipse x squared by 9 plus y squared by 16 equal to 1. X squared by 9 plus y squared by 16 equal to 1, touching the ellipse at Q and R. The angle between PQ and PR, now 3, 4 is this. Realize what's the director circle of this? X squared plus y squared is 9 plus 16, 25. Does 3, 4 lie on the director circle? Yes. If 3, 4 lies on the director circle, means this angle must be 90 degrees. This angle must be 90 degrees. Yes or no? Because 3, 4 is a point on the director circle, is that all right? So 90 degrees. Proceed. 20. There are two curves, a1x squared plus b1y squared equal to 1, and another curve, a2x squared plus b2y squared equal to 1. And these two curves intersect each other orthogonally. Means the tangent at the point where they intersect, these tangents are perpendicular to each other, right? So let's say this is one curve, this is C1, let's say this is another curve, C2, one curve C1, another curve C2, and they intersect at the point P, which is x comma y, right? The slope of the tangent here at x comma y into the slope of the tangent at x comma y for this must be -1. The tangents are perpendicular to each other at P. That's when we say the curves cut each other orthogonally or perpendicularly. The tangents would be perpendicular, so would the normals be, right? Now, if I differentiate this with respect to x, I get 2ax plus a1x plus 2b1y equal dy dx y prime equal to 0, or y prime, the slope of the tangent at x comma y is going to be minus a1 by b1 into x by y, minus a1 by b1 into x by y. That would be the slope of the tangent at x comma y for one curve. Yes or no? a1 by b1. For the other curve, this is for C1. For C2, the slope of the tangent, for C2, the slope of the tangent at x comma y would be similarly minus a2 by b2 into x by y. Yes or no? Right? And the product of these two slopes, dy dx, must be -1, leading to a1 a2 by b1 b2 into x squared by y squared equal to -1. Right? Or a1 a2 x squared plus b1 b2 y squared equal to 0. That's one. Okay, now xy satisfies this equation. This point P satisfies this equation. It satisfies this equation as well as this equation. So it satisfies 1, 2 and 3. All that you need to do here is you need to eliminate x square and y square. You just need to eliminate x square and y square. So from these three equations, how do you eliminate x square and y squared? How do you eliminate x square and y squared? I mean, essentially, yes. I mean, right here, you get a relationship between x square and y squared. So you can write x square as something into y squared, plug in this, plug in here, and you get the value of y squared, you get the value of x squared and plug into this. You can eliminate x square and y squared. You can eliminate x square and y squared. That would be the required eliminant. Using these three equations, just eliminate x square and y squared to connect the coefficients a1, a2, b1, b2. If you want, I'll do it for you. You think about it, otherwise I'll do it for you, right? If the equation of the family of ellipses x square by cos squared alpha plus y square by sin squared alpha equal to 1, where alpha is a parameter, so it's a family of ellipses. Alpha lies between 0 and pi by 4, which would cause cos squared alpha to be greater than sin squared alpha, right? Because alpha lies between 0 and pi by 4, cos squared alpha will be greater than sin squared alpha. So this would be like our a squared, this will be like the b squared, right? So we have a as cos alpha and b as sin alpha, a greater than b. Now, what's the eccentricity? The eccentricity would be such that e squared is 1 minus b squared by a squared. So 1 minus sin squared alpha by cos squared alpha, right? That will give me the eccentricity. Now we need to find the locus of the extremities of the latest rectum. So let's say the latest rectum has its endpoints as x comma y, then x would be squared by a, b squared by a would be x, ae would be x would be ae because it's from the focus, right? So x would be ae means a is cos alpha into root 1 minus sin squared alpha by cos squared alpha. That's x, right? The y would be b squared by a, y would be b squared by a, that is sin squared alpha by cos alpha. So now we have the x and y coordinates of the latest rectum in terms of the parameter alpha. I need to connect x and y by eliminating alpha, and that would be the locus of the ends of the latest rectum, right? Okay, so now let's do that. From this, equation 1, realize that this cos alpha, when it penetrates, or let's say x squared, becomes like a cos squared alpha minus sin squared alpha, which is 2 cos squared alpha minus 1, which is the same as 1 minus 2 sin squared alpha, right? 1 minus 2 sin squared alpha means sin squared alpha, realize, is y into cos alpha. So x squared can be written as 1 minus 2 sin squared alpha means 2y cos alpha. So far so good, right? I hope you realize x squared minus 1, x squared is 1 minus 2 sin squared alpha, where sin squared alpha I write as y into cos alpha. Or x squared minus 1 whole squared is 4y squared into cos squared alpha. 4y squared into cos squared alpha. Hey, but can I not write cos squared alpha as x squared plus 1 by 2? So 2y squared into x squared plus 1. Writing cos squared alpha as x squared plus 1 by 2. Right here. So that's x squared minus 1 whole square. So we've eliminated alpha. This then is the required locus of the ends of the latest rectum. So that makes option Bombay correct, option B correct. I mean, if you have a better way to eliminate, then you can share it with me. I'm open to that, right? A circle is inscribed in the ellipse x square by 16 plus y squared by 25 equal to 1, right? With center as one of its foci, with the center as one of its foci. The center of the circle is one of the foci of the ellipse. If a circle is tangent to the ellipse, then the radius of the circle is what we want to find out, right? So very clearly realize that it's not an ellipse like this, it's an ellipse like this. Its major axis will lie in the y direction. Its major axis will lie in the y direction. See, this is A smaller than B here, right? We have the ellipse. Something like this. This is the center. The eccentricity of the ellipse is 1 minus small by big, always small by big, right? So E is like 3 by 5. E is 3 by 5, the eccentricity of the ellipse. Now, the focus here, see, this length is how much? This length is 5 units, right? In the y direction, this is 5 units. So this would be 5 into E, this would be 5 into E, right? So the focus S is 0, 5E. That's a focus which is also a center of the required circle. So which is like 0, 3 is the focus. 0, 3 is the focus S. I hope all of you understand this. And this entire length is 5 units. Now, important thing. This is one focus, this is the other focus. Alright. Let's say segment of this ellipse, just an enlarged portion of this ellipse, and the circle touching. Right? If they touch, means they have a common normal. If they touch, that means they have a common normal. That means if this is the tangent, common normal. Now, normal for the circle would be a radial direction, right? So normal for the circle must pass through the center S of the circle, which is synonymous with the focus of the ellipse, right? Common normal means, again, realize that if this is the point of tangency of the circle with the ellipse, if this is the point where the circle touches the ellipse, then this is also a normal to the ellipse as well. This is right. This is also a normal to the ellipse, which means if a ray of light, forget the circle for a while. SP for sure is a normal to the ellipse, right? Because they have a common normal. If it's a normal to the circle, it also has to be a normal to the ellipse because they touch each other. They must have a common normal. Now imagine a ray of light that starts from S. Forget the circle, just look at the ellipse. Then at P, when it's incident, then its angle of incidence is 0 because it's incident normally, its angle of incidence is 0. So its angle of reflection must be 0. Okay, that means the ray of light would retrace its path. Wait, but if a ray of light starts from the focus, then after reflection it must pass through the other focus. That means the other focus must lie on the reflected ray, clearly meaning that S, P and S prime are collinear points. S, P and S prime must therefore be collinear points, right? So which means this must be the extremity. This must be the extremity of the major axis of the ellipse, must also be the point where the circle touches the ellipse, yes or no? And therefore, the radius of the circle, this is 5 units, and this we have found is 3 units. So the radius of the circle must be 2 units. The radius of the circle must be 2 units. Make sense? Huh? Shall we proceed? There are exactly 2 points on the ellipse. This is the ellipse. It's problem 23. X squared by a squared plus y squared by b squared equal to 1. Exactly 2 points on the ellipse whose distance from the center of the ellipse is root a squared plus 2b squared by we need to find the eccentricity of the ellipse. Hey, in general, if this is the ellipse, major axis, minor axis, center of the ellipse. Given a distance d, given a certain number d, in general, you can find 4 points on the ellipse at the same distance d. Yes or no? In general, you can find 4 points on the ellipse at a distance d. In general, forget that d, some d, call it d1. In general, if someone gives you a distance d1, then in general you can find 4 points on the ellipse at a distance d1 from its center. Yes or no? But if someone says that there are only 2 points at a distance d1 from the center, if someone says that there are only 2 points at a distance d1 from the center, then there are only 2 possibilities. Either those 2 points are the ends of the minor axis, or those 2 points are at the ends of the major axis. Yes or no? If someone says that there are only 2 points that are at a distance d1 from the center, then those 2 points will have one of the 2 possibilities. Either they would be at the ends of the minor axis, or they would be at the ends of the major axis, right? Okay. Now the 2 points at a distance d, these 2 points in question, they would either be at the ends of the major axis or would be ends of the minor axis, right? Now check this. This is like b squared plus a squared by 2. Yes or no? So which is clearly greater than b? That means they can't be at the ends of the minor axis, they must be at the ends of the major axis. Yes or no? These must be at the ends of the major axis. So then the distance g that we are talking of must be corresponding to points a and a prime, right? That means this distance d must also be equal to small a, the semi-major axis of the ellipse. Yes or no? This distance d must therefore be small a, this must therefore be small a, which means when I square a squared by 2 equal to b squared, square and transpose, or b squared by a squared is half, which is 1 minus e squared. So e then is 1 by root 2. E then is 1 by root 2. Right? That's the eccentricity of the ellipse. And one more thing. In this case, it's not that I assume that A must be the length of the semi-major axis. It's like if B was the length of the semi-major axis, then we couldn't have found a point at a distance larger than B. Right? You know what I'm saying? So obviously, B then must have been the minor axis. Because we are able to find, if it was the ends of the major axis, we couldn't have found a point at a distance D larger than B on the ellipse. And therefore, I can very quickly conclude that B must be the length of the semi-minor axis and not the semi-major axis for this situation. I have not assumed that B is smaller than A. I got B smaller than A for a situation of this kind. Are you confused? No? Shall I proceed? If tangents PQ and PR are drawn from a point on the circle x squared plus y squared equal to 25 to the ellipse this is an ellipse which is like a x squared by 16 plus y squared by b squared equal to 1 where b is less than 4. That means b must be semi-minor axis. B is less than 4 means it must be the semi-minor axis. So that the, okay, so now tangents PQ and PR. And this P lies on x squared plus y squared equal to 25. This P lies on x squared plus y squared equal to 25. So that the fourth vertex of the parallelogram PQRS lies on the circumcircle of the triangle PQR. No, that's not possible. This is, I'm sorry, it looks like an ellipse, but it's a circle. This is the circumcircle of triangle PQR. This is the circumcircle of the triangle PQR. And it's given that there is a point S. There is a point S on this circle such that PQRS is a parallelogram. In fact, it must be PQSR, which should be a parallelogram. Just change that to PQSR. Such that PQSR is a parallelogram. PQSR is a parallelogram. We need to find the value of the eccentricity of the ellipse. We need to find the value of the eccentricity of the ellipse. Now, PQSR is a parallelogram and it's also a cyclic quadrilateral. It's a parallelogram, it's also a cyclic quadrilateral. Now, in a parallelogram again, this angle will be the same as this angle. In a parallelogram, this angle will be the same as this angle. But in a cyclic quadrilateral, this plus this will be 180 degrees. That means this must be 90 degrees and this must be 90 degrees. To have compliance with a parallelogram as well as a cyclic quadrilateral, right? Which means the angle at P is 90 degrees. That means the two tangents drawn from P to the ellipse are at right angles. That means they must lie on the director circle. They must lie on the director circle. So this then is the director circle. P lies on this. So this then must be the director circle of this ellipse. So 16 plus b squared must be equal to 25. 16 plus b squared must therefore be equal to 25. So b must therefore be 3. And if b is 3, obviously the eccentricity is such that e squared is 1 minus 9 by 16. E therefore is root 7 by 4. E therefore is root 7 by 4. That's the eccentricity of the ellipse. Shall we move? We have an ellipse which is like a 9x squared plus 25y squared equal to 225. That means x squared by 29 plus 25, sorry, plus y squared by 9 equal to 1, right? X squared by 25 plus y squared by 9 equal to 1. That's the ellipse. And pxy be any point on the ellipse and these are the two foci f1 and f2. Easy to see. The perimeter, this plus this will always be 2a. That's the property. So then, and this is 2ae, the distance between the two foci. So then the required perimeter is going to be 2a into 1 plus e, 2a plus 2ae, where a is 5 and eccentricity is 1 minus 9 by 25. E therefore would be 4 by 5. Right? So you know E, A is 5, you can find the perimeter. You can find the perimeter of the. Shall I proceed? There is an ellipse which is like x squared by a squared plus 2a plus 2 whole square, okay, plus y squared by a squared plus 1 whole square equal to 1. That's an ellipse whose center is O. If the maximum radius of the circle centered at the origin and a normal is drawn to this ellipse, and a normal is drawn to this ellipse. If the maximum radius of the circle centered at the origin and touching the normal is 5, then the values of A are what? That's what we want to find. So now just for the ease of writing, let me write this as an ellipse as x squared by a squared plus y squared by b squared equal to 1. Let me write this ellipse as this now. At a certain point P, any point P on this ellipse can be written as A cos theta and B sin theta. Right? Any point on the ellipse could be written as this. Now at this point, a normal is drawn. A normal is drawn. What's the equation of the normal? At theta, ax sec theta minus by cosec theta is a squared minus b squared. That's the normal at theta. That's the normal at theta. Ax sec theta minus by cosec theta is a squared minus b squared. Clear? That's the normal at any theta. Now, what we are doing is, with the center of the ellipse as the center of a circle, we draw a circle. We draw a circle of radius r such that the normal is a tangent to that circle, such that the normal is a tangent to that circle. That's what we are drawing. We want to be able to find the maximum value of r. We want to be able to find the maximum value of r, or rather we want to find small a such that r is the maximum it could be. That's the intention here. Clear? We want to be able to find small r, rather small a, such that small r is the maximum. That's what we want to do. Now, what is r? R is the distance of 0, 0 from the normal. right? R is the distance of 0, 0 from the normal. So small r, distance of this line from the normal. Plug in everything on the same side, minus a squared minus b squared equal to 0. Put x equal to 0, y equal to 0, perpendicular distance of 0, 0 from this line. You get mod of a squared minus b squared divided by root a squared sec squared theta plus b squared cosec squared theta. We want R to be a maximum. This R is mod a squared minus b squared. I write sec squared theta as 1 plus tan squared theta, cosec squared theta as 1 plus cot squared theta, right? So I get in the denominator here a squared plus b squared plus a squared tan squared theta plus b squared cot squared theta is what I get, right? This I can write as a tan theta minus b cot theta whole square plus 2ab. Yes or no? This I can write as a tan theta whole square minus b cot theta whole square plus 2ab. That 2ab comes here to make it a plus b whole square, right? So then R becomes now R would be a maximum when the denominator is a minimum, right? R would be a maximum when the denominator is a minimum, right? Denominator minimum when this is 0. When this is 0, then the denominator would be minimum. Yes or no? When this becomes 0, then the denominator would be minimum, right? So maximum value of R is when this is 0. So then this becomes like a mod a squared minus b squared by root a plus b whole squared is mod a plus b. Is mod a plus b. So this becomes mod a minus b. That's R max. That's R max. And that's given to be equal to five. R max is given to be equal to 5 in the problem. Mod a minus b is given to be equal to 5. A minus b means this minus this. That's a minus b. But this minus this is 2a plus 1. So mod of 2a plus 1 is 5. Or 2a plus 1 is plus minus 5. So one of the values of a is 2. Other value of a is minus 3. These are the two values of a. Got me? Confused? No? Sorry? This 2a, 2 minus 1. Twenty-seven. There is an ellipse given which is like x squared by 16 plus y squared by 9 equal to 1. That's an ellipse. the maximum distance of the center of the ellipse, the maximum distance of the center of the ellipse from the chord of contact of mutually perpendicular tangent. Okay, what we have is on this ellipse, from various points P, H, K, from various points P, H, K, perpendicular tangents are drawn. Perpendicular tangents are drawn, yes or no? PQ and PR are perpendicular tangents drawn from various points P. That means this HK, all these HKs must lie on the rectangular circle. So in any case, whatever P is, which could be very many points, H squared plus K squared must be 16 plus 9, which is 25, always for various HKs, right? Now, for every HK, there would be a chord of contact. There would be a chord of contact for every HK, yes or no? And for every chord of contact, there would be a perpendicular distance of this chord of contact from the center of the ellipse, right? We need to find the maximum distance possible. For different HKs, you will have various distances available from the center of the ellipse. We want to find the maximum possible distance. We want to find the maximum possible distance. Now, first of all, the QRs, the various QRs in terms of the various HKs would be T equal to 0, which would be like a HX by 16 plus KY by 9 equal to 1. These are the various QRs. And the distance from the center D of the QR can be obtained when you plug in X equal to 0, Y equal to 0 in this, right? So then this would be 1 by root H squared by 256 plus K squared by 81. We want to find G max. We want to find G max. For different HKs satisfying this equation, we get different values of G, different values of G. We want to find the maximum D that could be obtained. We want to find the maximum D that could be obtained. Now, what I can do is I can write this K squared as 25 minus H squared, as 25 minus H squared. So let me just look at, to get D max, this should be a minimum, yes or no? To get D max, this should be a minimum. So what we are seeking is the least value of H squared by 256 plus K squared by 81. We want this to be the least, subject to the condition that H squared plus K squared is 25, right? We want the least value of this. Now this I could write as H squared by 256 plus 1 by 81, sorry, K squared, which is 25 minus H squared. We want this to be the least it could be. This is 25 by 81 minus H squared into 1 by 81 minus 1 by 256. We want this to be the least it could be. We want this to be the least it could be. Hey. Now this will be the least if H square is the maximum it could be. H square is the maximum. When H squared is max, realize that the maximum value of H squared is 25 here. Yes or no? The maximum value of H squared is 25, right? So H squared should be 25. H squared should be 25. So H, for example, could be 5. And if H is 5, then K is 0. If H is 5, then K is 0. H is 5, K is 0. So D max will be obtained for H equal to 0, 5 and K equal to 0. If you did that, then d max is 16 by 5. D max is 16 by 5. It could also have been for h equal to minus 5 and k equal to 0. Now, one thing, geometrically if you look at it, this is the ellipse. The point P lies on the director circle. The point P lies on the director circle. In an MCQ kind of a scenario, the point P could lie anywhere here, right? In an MCQ kind of a scenario, I'll tell you, I would have guessed this. I wouldn't have done all this. All this I did for the sake of the class and for the sake of the subject. But for the sake of an exam, I would have actually never done all these calculations here. I would have intuitively guessed that if the point P was here, which is 5, 0, this point is the circle. This is the circle x squared plus y squared equal to 25. The 5, 0 is a point here. And realize that from this point, if I draw the two tangents, then the chord of contact really would be the farthest from the center. And from this point, if I draw, then it will be the closest to the center. So either from this point or it will also have been from minus 5, 0. Then also the chord of contact would have been farthest from the center. If I draw the tangents from 0, 5, then the chord of contact, and 0, minus 5, then the chords of contact would be closest to the center. This I would have guessed intuitively. Intuitively is what I would have guessed. Or at least, if not that, I would have at least guessed that the maximum would be either if the point P is here or if the point P is there. One of the two situations, and for each of these, I would find out which one is larger, this or this. In the worst case, that will be a little ineffective, but I would still do this. I would take 0, 5 and I would take 5, 0, and from these 2 points, I'll find out the distance of the chord of contact from the center, and so on and so forth. I could have worked it out that way too. Not recommended, but this would have been easier to guess. The point P should have been here, which we worked out by calculations, the point P here, so that the chord of contact is farthest from the center, Clear? It certainly couldn't have been the maximum, couldn't have been here or here, because then they would have been uprolled. Then what's the difference between this point and this point or this point? Symmetry would mean that, well, for a maximum or minimum on either side, we must be able to obtain the same situation. But why should there be any bias for the point PHK to be located here and then get a maximum? There would have been a certain semblance of bias in the situation. We couldn't have had a bias. So all of these could have led you to believe that the point P would either be these two or these two. Then from the physical feel of the situation, I could have eliminated these two and I would have just frozen this point or that point to get this as the maximum. Clear? So we have an ellipse. This is problem 28. P is any point in the first quadrant on the ellipse x square by 4 plus y squared by 1 equal to 1. At this point P, a tangent is drawn intersecting the coordinate axis at A and B. At this point P, tangent drawn intersecting the coordinate axis at A and B. this P can be written as, let's say, 2 cos theta sine theta, y equal to 1 sine theta, right? Then the equation of the tangent AB is going to be x cos theta by 2 plus y sine theta equal to 1, right? Which you can write as x by 2 sec theta plus y by cosec theta equal to x by a plus y by b equal to 1. Readily giving me a as 2 sec theta comma 0 and b as 0 comma cosec theta. A circle is drawn with AB as the diameter, and the minimum area, so that, and we want minimum area of the circle. We want the minimum area of the circle whose diameter is AB. Then what should be the point P? That means if I can find theta such that the area of the circle with AB as the diameter is the least, right? So now what should be theta such that the area of the circle with AB the diameter is the least it could be. Now, evidently, if AB squared is the least, which is the square of the diameter, then the circle would have least area, right? But what's AB squared? AB squared is CA squared plus CB squared. So which is like a 4 sec squared theta plus cosec squared theta. Right? Write this as 1 plus tan squared theta, 1 plus cot squared theta. So we have 5 plus 4 tan squared theta plus cot squared theta. Right? This I can write as 2 tan theta minus cot theta whole squared plus 4 plus 4 plus 4 means this will become 9. Right? Which means AB squared is larger than or equal to 9, right? AB is greater than or equal to 3. AB is greater than or equal to 3, evidently. Right? That means least value of AB is 3. And when AB is 3, then this must be 0, this must be 0. That means 2 tan theta must be equal to cot theta, or tan theta must be 1 by root 2. Because it's in the first quadrant, we take the positive square root, right? Tan theta is 1 by root 2. And therefore, from this you can find sin theta as 1 by root 3 and cos theta as root 2 by root 3. So I know the point P, 2 into sin theta, 2 into cos theta and sin theta. I know the coordinates of the point P for the area of the circle to be the least. 2 cos theta and 2 sin theta. So 2 into root 2 by 3 and 1 by root 3. These are the coordinates of the point P for AB to be the least and therefore the area of the circle to be the least. So option C is correct. Are you all okay with this so far? X square by f of 4a plus y squared by f of a squared minus 5 represents an ellipse with major axis as y-axis and f is a decreasing function of x. F is a decreasing function of x. Then the interval to which a belongs. Now, obviously, if this is the major axis, then f of 4a must be less than f of a squared minus 5. This will give me the minor axis, this will give me the major axis. Right? So f of 4a must be less than f of a squared minus 5. Hey, if I have a function which is decreasing, if fx versus x is a decreasing function, and if f of x1 is greater than f of x2, I should say that x1 must be less than x2. For a decreasing function, if f of x1 is greater than f of x2, I can very easily claim that x1 must be less than x2, right? Yes or no? So, if f of x1 is less than f of x2, then this must be larger than this. Then 4a must be larger than a squared minus 5. F is a decreasing function because f is a decreasing function of x. Clear? Or I have a squared minus 4a plus minus 5 less than 0, right? Or a minus 5 into a plus 1 less than 0. Wavy curve method, this is minus 1, this is 5. So this product will be less than 0 when a belongs to minus 1 to 5. When a belongs to minus 1 to 5, this product would be less than, I hope you remember wavy curve method, right? A must lie between minus 1 and 5, minus 1 and 5. Not equal to minus 1, not equal to 5, but lying strictly with a belongs to minus 1 to 5, to the exclusion of minus 1 and 5. Clear? If the line x plus 2y plus 4 equal to 0, 30. Cuts the ellipse. This is the line x plus 2y plus 4 equal to 0. And cuts the ellipse in ellipses x squared by a squared plus y squared by b squared equal to 1. In points whose eccentric angles are 30 degrees and 60 degrees. So this is like a cos 30 degrees, b sine 30 degrees, and this point is A, and another point B, which is A cos 60 degrees, B sine 60 degrees. That's given in the problem. Right? Subtends a right angle at the origin. This AB subtends a right angle at the origin. Hey, how do I get the lines OA and OB? Ellipse with the line, I get the pairs of lines OA and OB. And these two lines would be perpendicular to each other, and then the perpendicularity would imply that coefficient of x squared plus coefficient of y squared must be 0, right? Recall that? So then, if I homogenize the ellipse with this line I can write as x plus 2y by minus 4 equal to 1. So this one I replace by x plus 2y by minus 4 whole square. Yes or no? Right? Now, coefficient of x squared, see, when I collect terms, then I have x squared into 1 by a squared minus 1 by 16. That's the coefficient of x squared. Plus there is coefficient of xy And then there is coefficient of y squared, which is y squared 1 by b squared minus 1 by 4. See? This would be 4y squared by 16. So y squared by 4 transposed on this side. This equal to 0, which gives me what? Pairs of lines OA and OB. And these two lines are perpendicular to each other. That means coefficient of x squared plus coefficient of y squared must be 0. I taught homogenizing to you, right? So that means 1 by a squared minus 1 by 16 is 1 by b squared minus 1 by 4. That's one equation between a and b. I need to solve for a and b. The other equation connecting a and b, look at this. The slope of this line joining a and b. The slope of this line joining a and b is like a b sine 60 degrees minus sine 30 degrees divided by a cos 60 degrees minus cos 30 degrees. That's the slope of AB. Hey, but that's equal to minus half. That's equal to minus half. That's another equation connecting A and B. Right? And using these two equations, you can solve for A and B. You can solve for A and B. That's all. Tangents are drawn to the ellipse x squared by a squared plus y squared by b squared equal to 1 at a point P. Oh no, not this one. The minimum area of the triangle formed by the tangent to the ellipse and the coordinate axis. At a point P, which is a cos theta, b sin theta, you draw a tangent. Then the equation of the tangent is x cos theta by a plus y sin theta by b equal to 1. That's the equation of the tangent, right? This could be written as x by a sec theta plus y by b cosec theta equal to 1. So a could be written as a sec theta 0 and b is 0 comma b cosec theta. We need to find the minimum area of OAB. For different thetas, we'll have different areas, right? So in general, area of OAB, delta, is half of a sec theta into b cosec theta. That's the area, half of this length into this length, right? So which is like AB by 2 cos theta sin theta, which is sin 2 theta, right? Sin 2 theta is always less than 1. So this will always be greater than AB. So this is always greater than or equal to AB. So that means delta minimum must be AB. Delta minimum must be AB. So far so good, right? An ellipse slides between two perpendicular straight lines. These are two perpendicular straight lines and this ellipse slides between these two lines. We need to find the locus of the center. Now, it's the same ellipse that's sliding. It's the same ellipse that's sliding. That means the physicality of the ellipse is not changing. That means the semi-major axis of the ellipse, A, and the semi-minor axis of the ellipse is not going to change. Right? Yes or no? The Radius of the director circle will also not change. The radius of the director circle will always be root semi-minor axis squared plus semi-major axis squared. Yes or no? Right? However, when this ellipse changes, the orientation of the major and the minor axis will change, all right? Right? But the eccentricity of the ellipse, the semi-major axis, the semi-minor axis will stay put, right? Now, so while this ellipse slides commensurate with the fact that the x and the y axis are tangential to the ellipse, the center C of the ellipse undertakes a certain trajectory, a path. We need to find the locus of the center. Now, one thing for sure, no matter what the orientation of the ellipse is, from the center, from the origin O, the two tangents drawn to the ellipse will be always perpendicular to each other. That means this O always lies on the director circle of whatever orientation the ellipse has. Whatever orientation the ellipse has, for any given orientation, the origin O will lie on the corresponding director circle, right? That means the distance from O to C will always be the radius of the director circle. The director circle will always be concentric with the ellipse. So the center of the ellipse will be the center of the director circle. So xy be the center of the ellipse, so also the center of the director circle. Then OC will at any point of time be the radius of the director circle. OC will be the radius of the director circle. So OC will always be root a square plus b squared. Yes or no? The radius of the director circle will always be root a square plus b squared. So OC, this is the origin O, x square plus y squared, therefore will be a square plus b squared. So where xy are the coordinates of the center C, that means the path taken up by C is a circle. The trajectory of C is a circle whose center is the origin of coordinates. While this ellipse slides, the center C undertakes a circular trajectory. Right? So the path of C is a. In my last class, I told you how to find the trajectory of the two foci, right? And now this one is simpler. This is the trajectory of the center of the ellipse. So we're talking of in 36, the focal distance of an end of the minor axis of an ellipse, its axis as x and y axis respectively, is k, and the distance between its foci is 2h. This is an ellipse x squared by a squared plus y squared by b squared equal to 1. This is the end of the minor axis. This is the focus S, center O. This distance of the focus from point, this is like x is 0, y is b. So this distance is a plus ex1. So which will be x is 0 for this. So it will be simply a. Distance of the focus from the end of the minor axis will be a plus ex1. x1 is 0 for this point. So this is a. And that's given to be equal to k. So we know a. A therefore is k. A therefore is k. So this a is known, right? And the distance between the two foci is 2h. That means 2ae is 2h, which is 2k, 2h. So then a is k. So then E therefore is h by k. E therefore is h by k. Right? So if E is h by k, then B is known. Right? B square is a square into 1 minus e square. So which is k squared into 1 minus h squared by k squared, which is like a k squared minus h squared. Or in fact, I could have just used Pythagoras theorem. Same thing, really doesn't make a difference. k squared minus h squared. Okay? Because this is h, half the distance, right? This is h and this is k. So b actually is root k squared minus h squared. This was not required. I could have just used this fact, right? This we found is k. This is h because this whole thing was 2h. So this must be h. So this is root k squared minus h squared. That's b. So b is known. B squared is k squared minus h squared. So x squared by a squared plus y squared by k squared minus h squared equal to 1 is the required ellipse. If the normal at point P of the ellipse meets the axis in R and S, we have an ellipse x squared by a squared plus y squared by b squared equal to 1. That's the ellipse, right? And the normal at a certain point P meets the x and the y axis in R and S. Okay, let me say the point P is a cos theta, b sin theta. That is theta, right? The normal at theta is ax sec theta minus by cosec theta is a squared minus b squared, which you can write as x by a squared minus b squared by a cos theta plus y by b squared minus a squared by b sin theta equal to 1, so that you readily get the x and the y intercepts. So the point R is a into cos theta comma 0. That's the point R. Intersection with the x-axis, the point S. Right? And the point P is this. We need to find the ratio PR is to PS. We need to find the ratio PR is to PS. PR squared by PS squared, realize is B squared by A whole squared cos squared theta plus B squared sin squared theta. Distance formula PR squared and PS squared is A squared cos squared theta plus A squared by B whole squared sin squared theta, right? I take like a b power 4 common from the numerator. Cos squared theta by a squared plus sin squared theta by b squared. I take a power 4 common from the denominator. So cos squared theta by a squared plus sin squared theta by b squared. This obviously gets cancelled. So PR squared by PS squared is b power 4 by a power 4. So PR is to PS is b squared is to a squared.